All right, so let's start off by going over the homework from last night. I asked you to verify the trig expression tangent times cotangent over cosine is equal to secant. So I know we just went over some basic ones yesterday, right? So I wanted to see how you handled this. It looks, they may look challenging, but once you kind of get the feel of it and changing everything and using our identities, hopefully you get more comfortable. Now, I did put up a list yesterday in the Google Classroom. Okay, if you noticed, I had the trig identities image there. So you can use that as a reference, right? These are the main ones up here are reciprocal, Pythagorean, and then we also use the quotient identities. The even and odd and cofunction we also went over. They are somewhat useful, but not as prevalent as the other three. All right, so you have those for reference in the future. You can save that picture, or it's on February 23rd's video lesson, so you can use that anytime you want. All right, so again, I didn't really give you major guidelines yesterday. Today, I'll give you some more strict guidelines, but remember, there's more than one way to do this. Okay, so if the method that I start using differs from what you did, okay, remember, as long as you end up with the same thing on both sides, you're in a good spot. So looking at this, we have the tangent, cotangent over cosine, and on this side, we have the secant, right? So remember, we're trying to simplify one side. So secant of x is pretty simplified, right? I can change that to, I can use the reciprocal rule and go 1 over cosine. That might help me here, but let's work with our left-hand side, right? We want to focus on one side. So I have tangent, cotangent, and cosine. So the cosine, remember, that's one of our basic ones, sine and cosine, so I'm going to leave that alone for now. Tangent and cotangent, I don't see any addition. I don't see any squares, so I'm not going to use Pythagorean identities. So let's use some of our quotient identities. We know that, I'll put it over here, that tangent is sine over cosine, and cotangent is cosine over sine. Right? So I can change both of those. So again, I'm going to leave this side alone. This side is going to stay secant x, and hopefully we'll try to match that. So rewriting this expression, okay, the tangent is sine of x over cosine x. The cotangent becomes cosine x over sine x, and we still have it all over cosine x. Now, what's nice over here is because this is multiplication and division, right? We can do elimination. Anything that we see in the numerator and in the denominator, the sines eliminate and the cosines eliminate. Okay, so that's one of our special properties of tangent and cotangent, right? Now be careful. I've seen in the past you eliminate everything, so you get nothing over cosine. All right, we're not removing everything, right? If I had x over x or 2 over 2, that wouldn't get us 0. That would get us a 1. So after we simplify the left side there, I have 1 over cosine x. And on the right side, I'm just bringing that down, secant x. And, well, this is one of our rules, right? This is a reciprocal rule. Secant is equal to 1 over cosine. So this side I can change to secant x. This side I have secant x. So we verified that they are equivalent. All right. So did anybody have any questions about that? So I know, some of you voiced your concerns before. So like I said, we're just going to do some practice.
No questions.
Okay. So here, what I have is some guidelines. Can you guys see that okay? Is it too far out, or do you want me to zoom in a little bit?
That's okay.
Okay. So if you need me to zoom in, I'll just do that. But this is nice because it fits everything here. So we have 5 main guidelines for verifying trig identities. All right, our first one is to work with one side of the equation at a time. All right, and that's what we've been doing. Okay, it's often better to start with the more complicated side, right? We want to simplify. It's hard to take, in this example, it'd be really hard to take this secant and expand it to look like this, right? I can use 1 over cosine, but how do I get from that to having extra terms, right? So take the more complicated side and stick with that side. You may hear me reference them to as the left-handed side and the right-handed side, or LHS and RHS. Okay, so that just means stick with the left side or stick with the right side of your equation. Your second step, look for opportunities to factor an expression, right? Remember, with our Pythagorean identities, we may be able to factor something out or factor a common term out. Look to square a binomial. So we did an example of that yesterday, also known as rationalizing, right? I'll show you a quick example before we practice. Or create a monomial denominator, right? So that was, again, the same thing where we kind of rationalized. We changed the denominator to be a little more cleaner, right? A little nicer looking. After we've factored and we've squared and we've done that, okay, then we're going to look for opportunities to use our identities, right? So our Pythagorean identities, sine squared plus cosine squared equals 1. Our reciprocal identities or our quotient identities. Okay, it is good to note which functions are in the final expression, right? So you have an endgame, right? So before, when we were just simplifying, you were just simplifying to get the equation to the smallest thing possible. Now we have an endgame. Now we have a target, okay? So if you see, okay, I have a sine over here, well, I'm looking for somehow to get a sine out of the left side or vice versa. So just as a reference, sine and cosine pair up nicely, especially if they're squared. Secant and tangent, okay? Cosecant and cotangent. Those are all pairs for our Pythagorean identities. Okay, and again, I gave those to you, so you'll have those for reference. We just saw too, right? Tangent and cotangent are kind of, I don't want to say inverse, but they're reciprocals of each other, so they eliminate each other, right? Tangent and cotangent. Cosine and secant are also a good pair. Secant and cosecant, right? If they're multiplied together, it gives us 1. If you're stuck, right? This was one of my main points. Try converting everything to sines and cosines. They are our most fundamental trig expressions, trig functions, right? And they're the easiest to work with. And the last guideline, always try something, okay? It's not going to be clear cut. It's not. Sometimes it'll be pretty simple. Sometimes you'll say, oh yeah, that's one of our rules. That's one of our identities, right? But try something if you're stuck, okay? Even making an attempt that leads to a dead end can say, all right, well, this didn't work. Well, the only other option I have is this, right? So using the process of elimination, things like that. All right, let's see. I did want, no, that's not my Precalculus book. So what you guys are going to do today is I'm going to pair you off into 2 groups, and I'm going to give you a problem, and one group is going to work on the left-hand side, and one group is going to work on the right-hand side. Now, I chose a specific problem where you can work on both sides, right? So one of you isn't going to be trying to make sine look like, tangent times cotangent times whatever. right? They're both interchangeable. But I did want to just refresh and give you guys a little hint, just in case you get stuck. I know we're just starting with this. I had another example. Sorry, 1 second. Oh, no. Okay, so real quick. Here we have cosecant x plus cotangent x equals sine over 1 minus cosine. Now this is kind of similar to what you're going to be doing in a second. Now, for those of you that are going to be working on the left-hand side, right, you kind of have a place to start by changing cosecant and cotangent. If you're going to be working on the right-hand side, right, remember what we did yesterday. How can I manipulate this side, or how can I start to manipulate this side? Say, say I just wanted to simplify, and I didn't have the left side. I didn't have an end game. What did we do yesterday to something that looked like this?
You multiplied. Oh, do you want us to tell you, or
Yeah,
is it just
go ahead.
Question?
What do I multiply by?
For the right side, the bottom, not the best word. So,
right.
1 minus.
So we're looking at them. So I would multiply that by what?
The numerator?
Close. If I was trying to add two fractions, yeah, we'd have to do that for getting a common denominator. That's something else that we did yesterday.
Didn't we use the Pythagorean identity?
Okay, so right. So this starts to look like a Pythagorean identity, but we don't have cosine squared. Okay, so good. So how did we get the cosine squared out of this?
We multiply by the denominator on the top and the bottom.
Okay, by the exact denominator, another 1 minus cosine. What happens when I multiply those two? I get if I multiply these two as they are, I get this. Does this look like a Pythagorean identity?
Yeah.
Close.
Yeah.
Right. This part here, we don't want that. That's ugly. So I don't multiply by the exact. I almost said it. The exact denominator. We multiply by the. Remember what we called that? No, it's not reciprocal. I almost said reciprocal, but it's not reciprocal. My mistake.
The opposite.
Now I'm blanking out. Conjugate. There we go. Right. So we have to multiply by the conjugate. Then in the denominator, right, we get 1 minus cosine squared, and we know that that is equal to sine, right? Okay. So what I'd like you to do is write down this. All right, so this is the expression we are going to be working with. Oh, somebody left. All right, so we have secant x plus tangent x equals cosine x over 1 minus sine x. So I am going to put you guys into groups, if I can. There we go. All right, and then once I have you guys in groups, I'm going to tell you which side you're working on. And then we'll get together, what is it, 10:50? Yeah, I'll give you guys like 6-7 minutes. All right, so let's do this.
Mr. Murray.
Oh, what's up?
I want to say like Jackie's laptop died, so that's why she left the meeting.
Oh, okay, that's okay. Thank you. I wasn't sure who left, but I did see it was somebody. Oh, Miss Maple's not here anymore. Do you guys want to do the group work, or would you rather just work on this together?
Can we work on it together, please? Because I'm kind of
Okay. All right, that's fine. All right. So I'll let you guys work on this with me. What side do you want to work on, the left or the right?
The right.
The right. Okay. So we're going to leave the secant and the tangent alone, and we're going to mess with the cosine. Or 1 minus sine. So what can I do here? I kind of just gave you the hint before all this. What are we going to do to this?
Multiply, but the denominator is conjugate.
Very good.
I may or may not have, the last problem, kind of like, yeah, you know what I mean.
Okay. Let me change it. All right, so we multiply by the conjugate. So I get cosine of x times 1 plus sine of x over 1 minus sine squared. What could be my next step? All right, so from this point, there's really only one first step that you can take, and that's using the conjugate. Here, though, okay, now it kind of branches off. Now we have different paths we can take. So what do you want to do next?
Use a Pythagorean identity, because isn't cosine squared equals 1 minus sine squared?
You got it, right? So I'm going to replace this with cosine squared. What could I do next? Again, there's a few steps that we can take. Let me ask you this. What if I had something that looked like this? If I have x over 1, x times 1 plus y over x squared, what can I do to simplify this expression? What's something that you see that we can simplify?
Factor out a cosine, or maybe do distributive property.
Yeah, you got it, right? So okay, so right, that's kind of where we can split. I can distribute the cosine, but then I'd be dealing with a sine times cosine, right? So I mean, it is an option. I forgot the word I was trying to use there. But it might make things more.
Sorry, I didn't mean to interrupt you.
That's okay.
You could.
So the other thing we can. I think you said it.
We could distribute and turn.
Okay.
Because yeah. Okay.
So you want to distribute?
Yeah.
All right.
So it'll Wouldn't that give you tangent? Or am I making that
What
up?
will give you tangent? Okay, this close, we have to have sine divided by cosine. So it looks like we might be able to get that somehow, but I got to get rid of some other things.
So why don't we get rid
So
of
this-
the cosine?
Okay, so right, so let's forget about this for now. Okay, but that, you know, that might help us in a second. But here, right, if I can eliminate one of these x's with this x,
¿Qué fue?
right? So I can eliminate
Tú le quieres
this
poner
cosine
comentario.
Poner un comentario.
with the
Esa
square.
ponerla no en las historias, sino que salga.
O tú la quieres poner no en la historia. So, tú me tenías que decir que no era en la historia.
Ah, pero la vamos a ponerlo con una música.
Okay.
I
Y
don't know what
después
you're
hacer
saying.
un comentario.
Sí, mira, so busca la música.
Primero la música.
Sí. Tú pones la música primero.
Ay, ¿qué música será?
I don't speak Spanish, sorry.
Oh, I'm sorry.
That's okay. All right. So we reduced the cosine. So this cosine is gone. And this looks a little nicer. And before we go any further, I just want you to notice that the cosine of x over 1 minus sine of x is the same as 1 plus sine of x over cosine of x. So that's just a neat equivalence that I think that it pops up. We'll see that pop up every once in a while. So I'm trying to get a secant and tangent. I'm almost there. What can I do here now? I did something like this yesterday. I don't know if you guys caught it. This is where it might get a little tricky if you're not used to doing stuff like this. Okay, just because we're running a little short of time. So here, as long as it's one term in the denominator, I can split up my numerator by making separate fractions, right? So I can have this 1 over cosine plus sine over cosine. Okay, so that's something that we're not really used to doing because, you know, normally we've been solving equations. So it's a little different, right? If I'm solving an equation and it's got a situation like this, my first thought isn't, all right, let me make this 2 separate fractions, right? That's kind of counterintuitive. I'm going in the opposite direction of simplifying. But for the trigonometry, okay, that might be a viable option. Now, Barbara, what do we see there? Sine over cosine.
And
Tangent. And 1 over cosine, we use the reciprocal rule. We get our secant. All right, so there we verified the identity.
Yay, so
All right.
smart.
For homework tonight, I want you guys to work on the other side. I want you to make secant and tangent look like that. All right, I'll put it up on Google on on the classroom. I'll make a form so you have a something to look at. All right, well, I want you to try to work the other way, and then we'll go over that tomorrow, and we'll practice some more complicated examples. All right, guys, thank you for your participation and cooperation. Have a great day. I'll see you all tomorrow.
you too. Bye.
Bye.